Hello everyone, and welcome back to the Houdini Academy Foundation module. In this video, we will have a look at how we can create the visualizers for our toolset, which are these colorful elements that you can see here on our tool. Now first let me cover what the visualizers on our tool actually do, and what in general they actually are. Now a visualizer on a Houdini tool is a type of visual element or mesh that displays information about our toolset to the user so they know what the tool is doing. It provides important information to the user that they need to know in order to use the tool properly, such as in this case we are displaying the grid which the elevators and the staircases are using to snap and position themselves inside the building. Next to this, I will also provide these arrow elements which show the orientation and position of the elevators and staircases as well. Plus, we can see over here I have a no symbol or a forbidden symbol, and this basically means that a part of the tool set, one of the elevators, is currently trying to place itself inside of a staircase, and I'm actually filtering that one out, and I'm giving feedback to the user that this is not actually possible, so I'm giving this icon instead. And then next we have these yellow lines which sit here in the sharp corners of our building, and these of course indicate where the windows will be removed on the upper floors if the corner is too sharp. So that we have the ability to set of course here in the building settings tab. Then at the bottom of our building we have the numbers for the tiles. Each column in our tiles here has a number, and we can use that to set, for example, where we want our doors to go. If we go to the doors and windows option, we can set it to pattern, and then we can specify by number where we want our doors to be. So this type of visual feedback is vital if we want to use this feature. And then last, we have the seam in the building. And the seam is where our tiles, as the numbering goes around the building, as you can see here, jumps up one floor and then continues on. And when it comes to the balconies, this is quite important, because later on when we build the balconies, they can go into different patterns as they go up the building, and controlling where the seam is will allow us to better control how the balconies switch as they go up the building, where they're basically cut. So we will also add the ability to move the seam in this lecture as well. Alright, so let's go over to the example files, and in this case I have the example files version 1.1. Now these are the example files that I'm gradually updating as I am building out the course. So at the end of the foundation module, when all the videos are released, you should be able to get this one from the download link instead. And I will also send out an email to everyone that hasn't gotten these files already, so you'll be able to get them then. But for now, let's dive into the network, and I'll show you what we'll be building in this lecture today. So the parts that we'll be working on in this video are these purple elements over here. And these are the visualizer components of our toolset. Up here we have the grid and the arrows for the top of our building. Then here on the left we have the lines on the side for the sharp corners and the seam. And then down here we have the numbers that we have on the side of our structure. These are all very simple elements, but together they give a lot of information to the user. And then finally, down here, we are going to load them all up using an object merge, and then we'll output them in the same way as we did over here for our main geometry, but we will output them as a separate mesh out here in the visualizer geometry container. So we're not actually going to output them from our main output node here. We are going to simply send them over to a separate geometry container using its own object merge. And if I look at that, this is what we'll basically send over. And this will be useful for the user. Later, when we also have our instances, these will also be displayed through this visualizer geometry, if you choose to display them as Houdini geometry instead of actual instances. This is what you need to do in Houdini, because in Houdini we don't have access to the actual mesh instancing that we have access to here in Unreal. We'll discuss more about that when we get to that in the next video. But for now, without any further ado, let's get started and let's open up our main project file. Okay, so we have about 4 different components to build for our visualizer. So let's get started with the more simple visualizers here on the left and set up the basic output system so that we can start adding more complex components into that after. So over here on the left, let's first deal with the seam of our building. Now the seam of our building comes directly from our tiles over here. If we look at our extrude walls section, located here, then we have our primitive numbers on our tiles. And what I would like to do is output a line right here between 0 and 51, so we can visualize where this seam is going to be. Because if we copy our floors up, you can see how the numbers actually jump up right at this location. So I want to show that to the user. Let's go ahead and drag off a line from our isolate walls node up here and pull it here to the left. I'm going to add a dot so it stays in place, using the Alt key of course. And then next, let's create a net box right here. And let's make it a nice size. And I'm going to name this one the Seam Visualizer. Now, because it's a visualizer, I am personally going to color this purple. I don't care per se which color of purple I will use as long as it doesn't obscure the nodes inside my network. I think this will do fine for us, so I'm going to go with that color for this network. So next, let's go ahead and drag a line from our dot and let's create a blast node. Now I'm going to color this blast node red and name it the isolate seam tile, or tiles actually in this case. Because what I want this blast node to do is grab the first and last tile in our entire bottom floor, so I can grab the seam from in between them. And I'm doing this because when we draw a curve, depending on the order in which we draw a curve, clockwise or counterclockwise, while we always make sure that it's pointing upwards, the point numbers do actually change. And that means that we can't predict if our seam is going to be on the left or the right. And I actually need to account for that. So in order to compensate for that, I'm going to select both primitive 0. And I need to make sure I delete non-selected, like so. And let's also make sure that we select our primitives, just to be sure. And then next to that, I also want to select the last primitive in our primitive row here. Now, in order to do that, since this is a group field, which is effectively a string field, if you want to evaluate an expression inside of a string field, you have to add it inside backticks, right? So you have to type 2 backticks, and then inside of this, we can then add a expression. In this case, I want to add the n-prims expression. And n-prims will retrieve the number of primitives from whatever geometry you specify to it. Now we can use, in this case, input 0, because input 0 is going to be the input of our blast node. So we will basically retrieve the total number of primitives coming into this blast node. Now if I do this, it's not actually going to work, because if we evaluate this expression by middle mouse clicking on this button here, you can see that it's trying to grab primitive 52, and primitive 52 is one primitive too many, because we actually started numbering at 0, but the number of primitives, of course, is 52, because if you include 0, you have 52 primitives. So let's go over here, and let's add, or rather subtract, one primitive number from that. So make sure that's inside the backticks, and then press enter. Now, this will have grabbed both the first and last primitive that's right in between our seam. Then next, what I would like to do is grab the normal from these tiles. Now that's pretty straightforward. Let's go ahead and create a normal node. And in this case, I just want to grab the point normal, which we don't have by default. So let's go ahead and set this to point normal. And then, now we need to extract the middle point between these two primitives. Now there are a couple of different methods in which we can go ahead and extract that one point here. We could use just a blast node and try to grab just point 1. Of course, that might break because I'm not 100% certain if point 1 will always be in the center of our tile here. I mean, you can see that number 4, 3, and 5 at the top aren't quite aligned. So instead of taking that risk and having some kind of situation where our building is a different shape, our tiles are in a different place, and suddenly our numbering is different, I'm instead going to use a more robust method. Now, of course, we can also use an attribute wrangle. I mean, attribute wrangles can solve anything, right? But sometimes there's a just slightly easier solution. I'm not saying that you shouldn't use an attribute wrangle, but you can also use a group expression node or two in order to achieve the same result. So let's go ahead and use those. Let's create two group expression nodes right here. I'll start with the first one. And the group expression node allows us to group a part of our geometry based on a simple vex expression. So in a way, we are still using vex, but we're using it in a slightly more controlled way. Now I'm going to call this one the seam point, this group. And let's call this group by expression node the seam point by neighbor count, or NBC. Now up here in the expression, what I'm going to do is I'm going to type neighbor count, and the neighbor count expression takes whatever geometry you specify. Then the second argument is whatever point number you're looking at, which in this case is going to be our current point number, so pt num. And then we can say if this particular point has 3 neighbors, I want to select it, right? So if I do this, then by default it's going to try to select primitives, which is not correct. So let's switch this thing over to point mode. And now you can see that it's basically selecting every point that has 3 neighbors, right? So this is the first part. With that, we now have 2 points selected, but I really want only my bottom point here. So in order to select that one, let's go ahead and grab a new group that only selects our bottom points, and then we can just intersect those to only keep our middle point. Let's grab this group node, copy it, and I'm going to rename this one to by bottom row. Now next we need to go ahead and change our vex expression around, and we can simply do that using the v@p.y expression. But if I do a simple is equals then 0, it will fail. And that's simply because our point position down here again has some fractional values, and vex is so accurate that it will fail that comparison, right? This is not 0. So unless we change these to integers, it's actually better to use a threshold value. So instead of doing a direct comparison, let's say if the current point position in y is less than 0.001. And this will work because our bottom row of our tiles is always going to be on our grid. Now at this point we have all these bottom points selected. That's because we are replacing our group right here. Let's switch it over to intersect with existing instead. So our seam point group will intersect with the previous version of the seam point group and only keep that middle point. Okay. And now we can just simply blast away all the other points and keep this one. So let's do that. Let's create a blast node. And I'm going to call this one isolate seam point. Select the seam point group. and make sure we specify it as a point group and say delete non-selected. Okay, so now we have the point at the bottom of our building, right on the middle of the seam. Let's go ahead and copy a line on top of that one. So let's create a line. This is going to be our seam line. Let's have a look at it at the center of our grid. Now I want this line to be about as tall as my building and then just 1 unit taller. We can do that very quickly, of course. We can just go to our building settings, grab our floor height, copy that, and then let's paste it into the length value of this line. Then let's multiply that by our total number of floors, so our floor count. And with that, we should now have a line that's about as tall as our current building. So let's visualize that. I just want it to be a little bit taller because this line is separate from our corner lines. So I'm just gonna add one more to it as well. So floor count plus say 1. And then because this is a multiplication and this here is an addition, we need to make sure that we add first. Let's add that inside brackets as well. So we first add these together and then we multiply. I don't want to keep hammering on this, but it's very important that you know how math priority works, because otherwise your equations will fail, right? Then next, let's add a copy to points node. And let's just plug this in. So our target point to copy to is going to be our seam point right here. And then our line goes in the first. Okay, there we go. Now, at this moment, this line is sitting exactly on the edge of our tiles. And if I put a visualizer on that, it won't look very well. It won't look very good. So what I want to do, if I look inside of Unreal, is just slightly offset my visualizer outward just a little bit, so it clears the outside of my building, and that will look just that little bit better. Okay, so going back in here, what I want to do is add a peak node. Let's plug it in before we copy our line, and since we have a normal on our point, I can simply use the peak node to transform this point outwards a little bit. Now I do want to give this a very small value, so let's just give it a value of 0.25, so 1/4 of a meter. That should be enough. Now at this point, this is not going to be visible inside of Unreal. While we can actually use polygon lines inside of Houdini, and they can form pretty good visualizers for Houdini tools, in Unreal it expects a mesh. So let's go ahead and create a polywire node. And the polywire node is a very simple SOP that can be used to create simple visualization meshes. It doesn't always create the most clean wires, especially when you have a lot of intersections in your mesh, a lot of intersections in your wire network, but we can get around that to some extent. Now the nice part is we can give it a width, but it's not super flexible, so keep that in mind. But for our purposes here, it's perfect. So let's go ahead and create a color node next. And I'm just going to color this wire a dark blue. In fact, if I select the color here, let's grab this one. I'm going to take the blue color and I'm going to boost it up over 1. And if you do this and you boost it high enough, you actually make your color brighter in your screen. I tend to use this for visualizers because it makes them pop and stand out, right? Now in this case we can use 2, that will work just fine. And then let's go ahead and grab a null node and create an output here that we can later merge back into an object merge. So let's color this one gray, and let's call it the out seam visualizer. Alright, so with that we now have our first visualizer done. Let's move on to the second one, and that's going to be for our corners. So this one is going to be pretty much the same. Let's go to our corner group here, which gives us these wires. And what I want to do is simply extract these out. Now, there is a way to grab a line from edge groups, and we can do that using the labs nodes. Specifically, there's the labs edge group to curve node, which will allow us to grab an edge group like this and turn it directly into a curve. As you can see here, it does work. But I don't want to rely too heavily on labs nodes, so I'm going to show you how we can do this in an alternative way as well. So I'm just gonna delete this one, or maybe put it on the side for now. And instead I'm going to just pull off another line, add a dot over here, and I'm going to create a new net box down here. Let's name this one the corner visualizer. And again, I'm going to color this one purple. And then in here, the first thing I want to do from our primitives over here is I want to make sure that I have the normals again. So let's create another normal node. This will give me the point normals pointing outwards, and if we ever have a corner like this, the point normals will average between the two primitives, so they're going to point outwards in between, right? Let me just change my shading around a bit. There we go. Then next, let's use a convert line node. And if I plug this in, then now we will simply have a lot of polygon lines along the edges of our original tile grid. And then I want to go ahead and transfer a group from my edges to select the ones right in between. So let's grab a group transfer node. Let's plug that in. And I'm going to call this one the transfer corner group. Then I want to grab an edge group from up here. So I'm going to pull a line from this dot, plug that in. And let's transfer the corner group right here. Make sure we set it to override. And as for the distance, I want to set the distance value to off. Because what this will do, if I show my edge groups, hide all these numbers, is it will transfer our groups from our original edge groups right here. And the reason this will work 100% of the time is because groups have a 0 or 1 state, an on or off state. And if we look at our original mesh here, we have edge groups on it, and every edge is either on or off. So the moment we do a transfer, even with its distance value turned off, like here, and as long as the geometry is overlapping, as we can see in this case, we don't have to worry about our transfers, because it will grab the closest edge from the source geometry and transfer it onto our lines. So it will always either be the correct on or the correct off state. And with that, we can now go ahead and filter out all of these not selected pieces of geometry. Let's grab a blast node and let's plug this in. We can go ahead and select our corner group here. If we say delete non-selected, it should work, because by default we can select edges. And with that, we now have our proper lines right there. So now let's go ahead and grab another peak node. because I still need to offset these lines from the walls, just like how we did up here. Let's zoom in a bit, and in this case I want to offset them at a distance of 0.35. And that's simply to prevent this line and this one from ever overlapping, if they ever do. Because this one's being offset at 0.25, our poly wire has a default size of 0.1, so as long as we offset it by at least that distance, just like in Unreal here, they should never completely overlap. They will just sit next to one another. And then let's go ahead and create another polywire and a color node right behind that. So let's copy this. In fact, let's copy this entire set here. Let's plug it in down below. Now the color node, in this case, if I look at this, I would like to color this yellow. And I'm going to use the yellow button right up here. And then I'm going to boost all these colors up again to a value of 2. That should make them extra bright inside of Unreal. So with that, we now have our corner visualizers done. Let's go ahead and rename this out node. And let's move on to the next visualizer right down here. And this one's going to be for our points down here, the ones at the bottom of our building. And these ones have an attribute called segment. So if we look at that one and we display it, let's find it. I think I still have it. Yes, here it is. So each one of these has its own number. And I want to be able to take this number and show it as a mesh, because otherwise we couldn't display it on Unreal, right? Now to do that, we need to run each of these points in a loop and then use a font node to create a piece of text on it. Now, just like before, let's go ahead and grab a line from this isolate ground floor spawn points here. Create a little dot. And let's create a new net box for this. Color it purple, and I'm going to call this one the segment number visualizer. Now these points, just like the lines, should be offset a little bit from our building. So before I go and copy any numbers onto them, let's grab another peak node, plug it in below, and as for the distance, let's offset them a bit further than the rest. Let's put them at 0.5. So they're properly away from the rest of our tiles. Then we need to go ahead and grab each of these numbers, each of these points, and copy numbers onto them. Like I mentioned, if you want to have a specific condition on your points in a loop, then you'll have to run every single unique value that we have here over its own loop. So let's do that. Let's go ahead and create a new for each loop. And in this case, I want to run it over for each by point. Now with this loop, let's go ahead and give it a quick name so we can differentiate it from the rest if we look for it. Let's call this one for each number viz. Let's put it on the begin block as well. And then inside of it, let's create a copy to points node. Now we need to plug the main line into the second input, because that's the target points to copy to. And then the first one here is going to be a font node. Let's plug that in. And if I just zoom in and hide all my visual elements here, then by default it's going to put a bit of text on every single point. Now we can change what it displays right here inside of the text field. Now we need to have it display the exact segment number, the segment attribute that's coming from our points themselves, right? In this case, this point here has segment ID 51. Now, to extract it, just like before, let's go ahead and create a null node that I can reference. I always like to do this with my loops. Keep the nodes that I'm referencing separate. Let's call this one the segment null, sure. And then this font node, which I'm going to call the font numbers, is going to create a spare input link to that, right? So let's just go ahead, on top of the font node, add a spare input, and let's grab this segment null and plug it in. Then next, inside of the font node, let's go to the text field, and I want to reference our segment point attribute from this null node. So inside backticks, again, because this is a string field, we need to put our expressions inside backticks or they won't evaluate. Otherwise, Houdini will just simply see them as text. And then we're going to type point, because we have a point reference here, point attribute reference. Let's set -1 for the geometry we want to reference from, which is our segment node here. Then we want to grab point 0, and we only have one point, of course. We're running over points, so we only have one point in here. Then we need to specify the segment attribute. And finally, we need to grab the first value from this attribute. Again, there's only one value, so specify 0. And with that, this font node should now be returning a number. There we go. Now by default, the font node is a bit dense on geometry. I don't need that many points. I don't need that many polygons. So let's go ahead and lower this a bit. In fact, we can lower it all the way down. Let's take our level of detail and lower it down to 0.001. I'm just going to keep the default font up here. If you want to change it, be my guest. You can also change other elements here, like the oblique angle if you want. But in this case, I'm just going to keep it default. What I am going to do though is maybe set its center up. So I'm going to grab its vertical alignment and switch that to bottom. Okay. Then maybe move it a little bit up from the floor. So let's raise that up by 0.5. So it sits a little bit higher in the tile. And as for its size, let's make it a little bit smaller as well. So 0.75. Okay. So now if we run the entire loop, we should now have numbers all the way around. Now we do have some alignment issues, and that's because of this peak node right up here. Let's go over to the peak node, and I want to make sure it does not recompute point normals, because right now all of our original point normals have been destroyed by it. Turn that off, and that should align all of our numbers properly. Yeah, okay. Okay, so next let's go ahead and add a little bit of color to these points, and I want to indicate the corner attribute as well. So if I just look here, you can see how near any of these corners with the corner lines, these tiles are affected. They are turned yellow. So we can do that very quickly if we grab a color node. And then over inside here, inside of our geometry, we still have our corner attribute as well, because this was copied over with the copy the points node. So if I go over here, I can change the color type from constant to ramp from attribute. And this will allow us to specify very simply, just like how we did before, down here, a color based on a ramp. So let's switch this over to corner. And then as for the colors, I'm going to grab the first value in this color ramp and set this to blue. I'm going to boost it up to 2 again. And then the final value, I'm going to set the yellow, because that's when our corners are true. I'm going to boost that up as well. So this should deal with the basic coloring and numbering for our tiles. Let's grab another null node. Paste it in below. And let's call this one the number visualizer. Okay, so at this point we have 3 of our 4 visualizers done. Of course, these are the simple ones. But before I continue, I just want to take these and I want to push them out to the output of our tool so we can see them inside of Unreal. Just quickly, let me grab these a bit, move them around so they're not quite as overlapping with the rest. Keep our network nice and neat. Okay, so with that, down below, let's go down here and add a new netbox. This one's the meshes output. Next to it, we're going to create the visualizer output. So I like to put my outputs down below in the network if I can help it. And again, because this is a visualizer, let's color it purple, just like the rest. So inside this network, I will have to create a couple of different components later. We will also have to add the visualizer for the meshes when we have the objects on the roof. But the first part we need, of course, is our visualizer component. So let's add that one first. Let's create an object merge. And this one, I'm going to call the in visualizers. Now, we need to go ahead and grab our different elements from here. So inside of our object reference, grab this button. And you can see that all of our out nulls are right at the top. And this is the nice part about using camel case naming. If you always start your nodes with a lowercase letter and you use uppercase selectively, then you can always grab that at the very top of your list. You don't have to filter all the time. So let's start by grabbing the corner visualizer first. Then let's go ahead and add 2 more entries and grab the other 2 as well. So we have our seam. And then we have our numbers. Okay, so now we have this. I want to add a control to be able to turn on and off the visualizer. So let's add a switch right here. And I'm going to call this one show visualizers. Let's add a null node on the other end so we can simply turn this on or off. Because this is an object merge, you could also add this to the enable buttons here, but that would simply just mean you have to hook it up to every single one of them. Adding a switch is a bit easier, so let's go with that. Then let's go to the type properties. And in here, at the bottom, in our setup tab, I want to add a new parameter right here. So let's grab our switch, drop it in. Let's add a separator. And I'm going to change this switch to a toggle. So we just have an on and off button. And let's call it the show visualizer. As for its default value, I'm going to leave it set to 1. And let's go ahead and click accept. So with that, we should now have the ability to toggle this on and off from the parameter menu. Let's grab that. And under setup, we can now enable or disable that. Okay. Okay, so next let's go ahead and clean up our geometry, because right now we do have some attributes and some groups on here that I want to get rid of. We already did this before, so over here, let's go ahead and copy our normal and clean attributes node. Paste it in over here. Now I want to keep my normal like this, by vertices, by face area, and the clean attributes node is also set up properly. And then next, let's also add a group delete node. Let's call this one clean groups as well. And I just want to delete all groups that come into this node. Okay, so asterisk symbol will do. And this should have cleaned up all this information. So next, we need to go ahead and output this. Now, since we're using an object level asset, I want to bring this into a separate piece of geometry than just this output node. If we wanted to keep these two as separate meshes inside of Unreal, then we could do that by taking this geometry and packing it. But packing basically means that we put this inside of a sort of a zip format, packed geometry, and some attributes like the color attribute are maintained, other attributes are sort of unified, they're kind of hidden inside of the zip format, inside of this package. I'm not going to go into that too much right now, but with a packed geometry we could take this and we could plug it over here into a merge node with the output of the rest of our geometry. But I don't really want to do that here. We don't have to do that. That's something you have to do if you're using a surface operator asset. Because we are using an object level asset, we can output it to a separate geometry container. Right? So let's go ahead and plug this in. And then we're going to call this one out visualizer. Now, I do want to add this to its own group, and we just deleted all of our groups. Just like over here, we have our mesh group. I'm going to copy this, and I'm just going to plug it in here. And instead of mesh, I'm going to call this one mesh visualizer. Okay, so with this, let's go out of our network. And inside of the first layer of our tool, I'm going to create a new geometry container. And I'm going to call this one the visualizer geometry. In here, let's go ahead and add an object merge. And I'm going to call this one in visualizer geo. Let's grab our geometry from the other part of the network. In this case, it should be all the way at the top here. Let's see, it is out visualizer. Accept that. So here we go. Now we have our data. And then we can simply grab an output node and output it from here. Now, at this moment, Unreal does have that collision glitch, and if I output this geometry like this, it will actually have collision. If this has been fixed in your version, you don't need to do this next part. But basically what I'm going to do is I'm going to add a merge node in here. And then let's add a simple grid. Just a grid object. And I'm going to make this very low res and very small. Just 0.1 in size, 2 by 2. And let's call this one dummy collision. Because it's not really going to do much. Then over from our original network, let's go over here. And I'm going to copy this collision geo group node right there. Let's paste it in here. And then plug it up like so. And this will create an extra collision geometry object inside of Unreal, if we look inside of our tool, we can find that it is going to create a little grid object for us. Like I said, this is only to bypass this glitch right now, because I don't want it to generate collision with my visual elements. I want to be able to walk right through them if they're actually in my screen. So if this has been fixed, you don't need to do this. But with this, we now have this set up. Let's go ahead and save this out. And then inside of Unreal, close that. Let's refresh our tool. So right click, re-import, and then rebuild. And well, it seems we have an issue. Let's go ahead and double check what's going on. So back inside of our tool, we have our building asset. Maybe I didn't actually render out my output node. Let's double check that. Yeah, let's make sure this is rendered. Let's save it. Go back here. Re-import. Select the tool, which we might have to do up here. Rebuild. Okay, so yeah, Unreal is actually sensitive to which render flag is being set in your network. Unfortunately, unlike some Houdini nodes, the output node isn't always respected. So yeah, it's a bit of a problem. Make sure your output node is rendered. Okay, so now if I go and play, we have our numbers. They're here. We can walk straight through them, they're not blocking us. And we also have our seam line right there. Now, speaking of the seam, let's go ahead and integrate that one as well, because we don't have any control over it at the moment, of course. So let's go over here. So out here, where we have our extrude walls, right before we do our seam visualizer, let's go ahead and add a sort node next. So below our isolate wall section, where we have our wall section and the numbers, let's add a sort node. Grab these lines, plug those in. And I'm going to call this one Shift Entire Facade. And in this case, we need to shift our primitive numbers around using a value. So the sort node allows us to change the order in which we have our points or our primitives. Well, in this case, I want to change my primitive sorting over to shift. And with that, we can shift our numbers around our building, basically. Offset them, if you will. So we can grab this offset value, open up our type properties again, and let's go over to my building settings over here. Let's drag a new separator into that. And then let's grab the offset value and drag it below that. So this one is going to be our facade seam offset. And as for its exact offset, I'm going to lock this at 0. I'm going to leave it up to you how high you want this number to be, but then let's go ahead and apply it. Now with that, if I just go to the tool and I show all of my objects so I can see the other container as well. And now, from our building settings tab, we can now move our facade around. Now this is going to recook our tiles, so it is going to take a little bit of time to calculate, but this will allow us to change where our numbering starts, and well, that's pretty useful. Now at the moment, it's always sorting in the counterclockwise direction, But of course, if we flip our curve direction around, if we draw our building in the other orientation, then the ordering of these points will be in the opposite direction. So we can fix that from our sort node up here. We can flip around our primitive sorting, and that will change the direction in which our tile set is sorting. So let's go ahead and add that one too. So up here, let's grab this toggle, drag it in, and we'll just call this one reverse facade sorting. Or order, maybe. Okay, so with that, we now have control over our facade as well. Nice. Okay, so at this point, we now have half of our visualizer completed. We have our lines and our numbers, and we also have our output, and it's been tested and working in Unreal. So with that, let's go ahead and start working on the grid on top of our building next. So up here, let me grab this network and let's move it over a little bit so I can create a bit of space down here. So I'm going to grab these nodes, just scoot them a little bit closer to one another. Nothing too complex, just making a bit of space. Okay, so next what I would like to do is go ahead and fix a little problem that we have with our current setup for the staircases and the elevators. And this involves an edge case in case we have multiple staircases or elevators that reside in the same tile or the same grid space. So let me show that and hide my other components. So at this moment we have 1 point over here. 1 point for the elevator and 1 point for the staircase. But let's say we have multiple points. And let's say some of these points overlap the same grid, which means we would actually suddenly build multiple elevators or multiple staircases in the same spot. I want to avoid this by limiting how many it can create in one location at the same time. And likewise, if we have our staircase boxes here, if we have an elevator that spawns somewhere inside of a staircase box, I don't want it to spawn at all. The staircases are bigger than the elevators, so I'm going to give those priority. And we can't exactly make these staircases themselves avoid this issue, because we will get infinite recursion errors. But for the elevators and the staircases, it's pretty easy to set up. And now that we have the delete by distance node over here, we can do this really quickly as well. But first, let's go ahead and deal with the case if we have multiple objects overlapping the same tile. To do that, of course, we need to go up to the top of our tool, and I need to add a couple of extra points. Now I already set something up. Over here I have a second curve, and if I enable that, you can see how I've added additional points for our elevator, and over here I have one that overlaps my current staircases. If I go ahead and show the other parts of my tool, you can see how all these points reside in the same grid, and over here this elevator point resides on top of a staircase. Well, we're going to have to deal with that. Likewise, for the staircases, I have another set of points here. And in this case, I have added additional staircase points in the same tile as well. And these will aim in different orientations at the same time. So, if I go up to the top of the tool, and then back into the tool, you'll see how now it's actually overlapping multiple staircases and elevators in the same space. And I can make this even clearer if I go ahead and show my primitive numbers, because we do have multiple primitive numbers here overlapping one another. Multiple elevators or elevator shapes are currently residing in the same place. And here it's obvious, we have two staircases that overlap and they're pointing in different orientations. So let's go ahead and fix that first. Up here, when we have our snapping points, we can see that we have multiple points overlapping one another. And of course, this is going to cause a problem. Right now, there are multiple points in this tile, for example, and they're all pointing in different orientations. Well, if we're later going to copy our elevators onto that, we won't even be able to use them because they will block each other's entrances. And even if they were all pointing in the same direction, we still wouldn't have a good mesh because we just have duplicate geometry sitting on top of itself. So in order to prevent that, we should actually fuse this point so we only have one point per grid segment here. Now the reason they're all pointing in different orientations is simply because each point of this set is actually orienting from a different quadrant of this grid. Point 1 here is just inside the tile and makes this point aim there. Then we have 2 and 3 and they aim left and right. Now in order to prioritize which point it will actually grab over the others, we can use a fuse node and then fuse based on a particular priority. Let's grab a fuse node. Let's plug that in. And I'm going to call this one the fuse overlap n from first. Now, by default, the fuse node is going to fuse the first point that it gets in a set. And because I'm fusing at a very small distance, all the points that are currently already overlapping each other are going to get fused, and then it's going to prioritize the first point it finds, which of course is this point over here. So that's the direction it's pointing in. But we can actually override this behavior. Now, this is the default behavior of the fuse node on the 2.0 fuse. This node was updated a few years ago and now has this default behavior where it aims towards the first point that it finds. But we can actually override it down here under attributes to snap and groups to snap. So if there are groups or attributes present on our source points, these ones, we can choose which ones it should prioritize when it fuses our points. Let's go ahead and add a new attribute override here. And I want of course set this to the normal. And then from there, the first option we're going to find is first match. So that's the default behavior. But if we go ahead and change this to say last match, then now our normal will switch around and aim towards the last point that it tries to fuse in this set. And we can see that if I just quickly grab a merge node and plug this in, that right now it's aiming towards the last point of these 3. Otherwise it will be aiming towards the first. Now we can do similar things with this option. We can also use it to fuse other attributes together. If each of these points had their own attribute, we could use that as a means to either grab an average, we can grab the maximum value, the minimum value, the mode, the median, or the sum. That's all very similar to the attribute promote node. But then first and last match can of course be used to just pick the order of our points. And if you want to make sure that it fuses in a very particular order, say in the order of an attribute, you can even go ahead and grab a sort node and pre-sort your point order. And if you do this, let's say I randomize my point order right here, then we can actually make it point towards any of these points randomly. So this is one way to do it. You can also grab another attribute and then use that attribute to determine the order of our points. So in this case, if we have an attribute that has a first value here on this point, point 2, then the sort order would make this point the first point, and then we could set first match, which means that it will start pointing towards that point based on an original attribute. That's a very interesting trick. We might use it in the future actually, but for now, let's go ahead and continue from here. So let's grab our fuse node, and I'm just going to color this blue because it does affect an attribute. And then from there, let's copy this over and put it on our staircases as well, because they also have a couple of overlapping points that we have to fix. Now, if we look at the end of our network, the first thing you'll notice is that now we actually have only one box in each location, right? We no longer have any overlapping primitive numbers. But we still have an elevator that's currently occupying the same space as a staircase. And because staircases and elevators reside in two different data sets, we need to fix this. But to be honest, at this point, that's not really such a big problem. In fact, we already have the node that we need to fix this issue. We have our delete by distance node, which we created in the last lecture. So let's go ahead and create a new one right here and fix this issue real quick. Let's go ahead and look at our elevators for a minute. And what I want to do is remove them if they are ever overlapping one of our staircase shafts. So right there. And if I grab a delete by distance node, plug it in, then I can now hook up our first point to be deleted if it ever overlaps one of these boxes. So I'm going to scroll down, go to our staircase shaft here and create a new object merge. Copy this, plug it in here, and I'll call this one in staircase shaft. And then under object, let's reference this null node. Okay, so now we have our box. Let's grab this merge node and pull it up here. And in this case, there's no issue because we are going to affect the left stream, which is not directly descendant from this node here. So we can just plug it in like that. And now, if I set this up correctly, what I want to do is for this point here to be removed in case it overlaps one of these staircase shaft objects. So I'm going to say we're going to detect primitives, and this already works, but because our points may actually reside somewhere else, I'm just going to flatten it as well. So in any case, it's going to make sure that in 2D space, if this point is anywhere above or below this primitive, this shape here, it's going to be selected. Now at this point, the distance threshold is far too large. It's currently 1 unit. And you can see that if I make this too large, it will even start affecting the other points as well. There we go. So if we go too big, then it will simply remove those. And I don't want any nearby points to be removed if they're in the next tile over, right? So in order to prevent that, let's just set it to a very low value, like 0.001. Because we're using our pre-flatten option, this should not be any problem. So with that, we are now removing our point. But I don't really want to remove the point because I do want to provide a visual element on our tool that indicates that we have actually overlapped an elevator with our staircase. And for that, if I remove the point, we will never get to see this. So instead of actually deleting the point, let's go ahead and simply group it. And then we can filter it out later instead. Let's create a group. And now, under our groups, under point groups, we can see that we now have a group here for this point. And let's go ahead and call this group the overlap group. All right. So with that, we can now go ahead and delete the point because now we have a place to pull it from when we need it later. Let's create a blast node. Plug this in. And I'm going to call this one remove overlap. Let's plug it into our delete by distance node right here. And select our overlap group. Just to make sure, I'm going to make sure it sets the points as well. Okay, so with that, we now have our points called. If I look at the final part of the tool, we can see we now have 2 elevator objects right here, and they're not overlapping anything. And we have our staircase here, which only has itself. There's no second staircase, and there's also no elevator overlapping it. Now, in case we have 2 staircases overlapping the same way like the elevator was overlapping this one, and they're not in the same point space, it's a bit more tricky to fix that, because if we try to use our delete by distance node for that, and we try to grab the staircase shaft here, we would cause an infinite recursion loop, because we'd basically be requesting data from here, which comes after this node. So that's not as easily done. For that, we'd have to create something like a for loop with feedback, and then per iteration go on and delete a point that overlapped the previous iteration. I'm not going to go into that right now. It's a little bit more involved, and we'll cover this in later modules of the master class. But for now, let's go ahead and continue and build our visualizer. So down below here, what I would like to do is create a new netbox. And I'm going to make this one reasonably sized. And again, I'll color it purple. And let's call this one the grid visualizers. Then, the first thing that I would like to do is create an arrow object that we can use to visualize our different points. Because right now we have our points, and they have a normal. In this case, we also have our overlap group on it as well. I want to make sure that we can visualize this with a mesh, because we cannot actually view these points in Unreal, right? We need a mesh for that. Let's create a new curve right here. And let's start with the arrow object that we have on top of our buildings. This one. Now in this case, we're going to do a little bit of quick modeling. We're not actually going to use a whole lot of procedural setups here. Let's just visualize our grid, make sure we can see the center of our world. Let's press the G key with nothing selected. That will zoom in on the center. And then I want to make sure that we aim in the Z positive direction, because that's the forward direction for most copies. Now if you can't see it because it's overlapping, again, you can always go to the guides and show the origin nomen. Alright, so let's start drawing. I'm going to grab my handle, and then from here, let's just draw a very simple shape. Let's say we start over here in this corner. Draw a line. Let's say like this. And then let's press enter. And then I want to close my curve. Now, if this thing is upside down, go ahead and reverse the curve as well, so it's facing upwards. In this case, I don't care about any kind of procedural cleaning like we did before. This is just going to be a little mesh that we pre-create and then copy onto our points. Then let's go ahead and create a poly extrude. And let's give this arrow a little bit of depth as well. So over here, let's increase the depth value. Let's set this to like 0.25. Okay, should be enough. And as for the bottom, let's also output the back, so we have a solid arrow mesh. Okay, then let's go ahead and create a copy to points node, and let's instantiate this one. I'm going to grab my elevators over here, and in this case I want to grab my delete by distance node here, not the blast node. I'm going to pull a line and plug it in over here into the second input, our target points to copy to. And then let's go ahead and plug this one into there. So with that, we now have a couple of arrows being placed on top of our points. Let me quickly show the grid again so we can see that one. And that works. But all these arrows are currently in the center of these grids, and I would like them to be a little bit offset. So let's just add a transform node in here. And I'm just going to push this arrow over, forward a little bit. This of course will copy them in their own direction, so they all get moved along their own angle, their own alignment. Let's set this one to a distance of 0.75. That should reside somewhere in the middle of this tile. Now, if we make our tiles bigger or smaller, this might not fit quite as well. For a default size of 4, this is going to work just fine. If we need to, we can always scale these arrows bigger or smaller if we increase our grid size using the point scale attribute. Then next, let's add a little bit of color to these arrows. Let's add a color node. And we can do this either above or below the copy the points node. But in this case, I want to set up a separate visualizer for this arrow and turn it into a no symbol because it's actually overlapping our elevator, if you recall. So any point that's part of a group, the overlap group, I want to actually change into a different icon instead. And we'll deal with that in a minute. First, let's plug this in. And let's color this one something like blue. This will do. In this case, I'm not going to boost the colors up too much, so let's keep it at a default 0 to 1 range. And I'm going to color this one color elevator arrow. And also let's give these other nodes some names as well. So this one is going to be the copy the points for the elevator arrows. Then this poly extrude, let's call this poly extrude icon. This is going to be the transform offset for the icon. And then our curve, well, we can call this one arrow. Okay. So next, let's go ahead and set the same thing up for our staircases. And then we'll deal with the no icon, the one that indicates that something cannot be placed, later. So let's go ahead and create a copy of this part here. Paste it over to the right. And I'm just going to plug that straight into our fuse node for the staircases. Now for the staircases, I want to use a different color. In this case, it's a bit arbitrary what color we're using. I mean, you could also create a custom icon specifically for the staircases and then one for the elevators instead of changing the color. But I'm not going to make this too complicated here. So let's change this to, say, something yellow or maybe something orange. That will do. You choose your own colors, of course. And let's rename these ones to staircase arrow and staircase arrow color node. Okay. So next, let's go ahead and grab a merge node. Plug this together. And I'll call this one merge grid visualizers. And now I would like to add the grid around these arrows. So up here, we already have our grid. If I go up in the network and I look for my convert line node, I can pull a line straight from here, which will give me my grid. Of course, again, these are polylines, and while we can use these in Houdini, we cannot use them in Unreal. So let's grab another polywire node and let's create one right here. Now at this point, this polywire, if we look at this a bit closer, is creating a pretty dirty mesh. And that is directly related to how these edges are interconnected. It's not a particularly good quality mesh for us to use. So I would like to fix that. Now instead of getting all complicated with how this is generated, I'm just going to disconnect every single one of the points in between these polylines. And if I do that, then it will generate one solid mesh for every single line without trying to fuse them in the middle points. And this will actually create a better, cleaner result for us. So let's create a unique points node. And the unique points node, very simple. It simply takes all of our points and splits them apart. So without it, these were fused. And with it, it completely separates all of them. So these are all separated polylines. And this will make our polywire return a nice and clean result for us, even though in our corners it doesn't actually create proper beveling or cornering. But I don't really care too much about that. In the end, this is a visualizer. It just needs to do its job. And then finally, let's go ahead and color this grid as well. Now, if these lines here get in the way, we can actually, of course, go and pull a dot on them and drag them over to the side. So we don't actually have them sit in the middle of our net boxes, being all in the way of our work, right? I always like to keep my networks clean. But like I said, let's grab a color node and let's plug it in below our polywire. And let's call this one the color grid. Now in this case, I'm going to make this one bright blue or dark blue, but over bright, because this is actually one of the line elements I do want to accentuate. So over here, let's set this to 0, 0, and 2. That'll make it a little brighter. And I'll make it stand out too. Now, do make sure that everything here is a point color, because in the end, we need to make sure that all the colors being merged on our output are the same type, the same element type. And we're using point color at the moment. And let's plug this in. Okay, so that's our basic grid completed. Now, at this point, it's still sitting at the bottom of our building. If I template out my building, then it's currently, well, inside the ground, not something we can use. So let's grab a transform node, plug it in here, and let's raise this thing up to the roof. And I would like to grab my current floor count, the current height that we're using, just like how we did here for our seam visualizer. So over here we have our seam line, and in this one we already have an expression that describes an extra high point above our building. Let's just grab this one and copy it over. Let's call this one raise above roof. And then paste it in to the Y channel. Okay, so now we have our grid on top of our building. If you want to raise it a little bit more, you can always go ahead and add a little bit extra, so like 0.01 or something. And then let's create a null node so we can output it to our merge. Let's call this one out grid visualizer. Make it gray. Copy that. And then down below, let's plug this in as well. Okay, so now we have part, at least, of our grid mesh completed. But we still need to deal with those no symbols that I mentioned. And that involves a little bit of extra logic that we need to set up here. Now we're only going to need them over here for our elevator arrows, because like I mentioned, we can't actually make this work easily for the staircases, because this would cause well, all kinds of recursion loop issues. So let's grab these nodes, pull them down a bit, let's create a little bit more space. I'm going to grab the arrow icon here and wrap it into its own netbox. And if you want to make sure a netbox sits inside of another netbox, you can always grab it, wiggle it around, drop it on top of the other one, and this should make sure that it sits on top. If it's not sitting on top, then grabbing the top netbox will mean the bottom one won't come along, and it will also be a little bit darker than the other ones. Now, nesting netboxes is fine, but if you do it too much, they do over brighten a bit, because they are an additive color, and they will add on top of one another, and eventually it will become so bright that you'll have trouble seeing the elements inside. So do keep that in mind. They do become a little hard to see if you nest them too much. So let's call this one the arrow icon. And I'll call this one blue. And then next to it, let's create another netbox. And I'm going to call this one the invalid icon. Okay. Now to make this icon, let's create a circle. because we want to create this no icon, let's start with a circle. Again, let's go to our grid center, visualize that, and I would like to grab this circle and move it into the ZX plane. Then let's change it over from a primitive to a polygon first. This will give it some faceting. Now at this moment it's upside down, and in this case that's not actually such a big problem, because if we look at our example file, you can see how in case we have an elevator sitting on top of a staircase, I actually want those no icons to reside slightly lower than our arrow. And if we extrude it downwards along its own normal direction, then that will already solve our problem for us. So with that, let's go ahead and turn this into an actual circular shape with a hole inside. So we have the base shape for our no, right? Let's create a poly extrude. And let's call this one the poly extrude inset. Then as for its inset distance, let's push this up a little bit and see where it fits. 0.3 seems to work nicely. Now, if we are going to ever take our circle and shrink it down, like make its uniform size smaller, then this inset won't work quite well. So I want to link these two up. So if I make my circle smaller, then my inset will also shrink as well. Let's grab this, copy that, maybe set it to 0.7 here so we can see. And then under my poly extrude inset, I'm going to paste this in and multiply this back with 0.3, the value that we saw that worked well with a value of 1. Okay, so with that, now, no matter on the size of our circle, it should stay proportional. Alright, let's keep it at 0.7. And then under our poly extrude inset, let's turn off the front. So we have a hollow inside. Then next, let's go ahead and bridge this gap. Now we can do this using a poly bridge node. And for that, up here in my screen, I'm going to open up my shelf, because I'm kind of manually modeling here. And I'm going to look for the poly bridge node, which is located in the polygon tab right here. Now to use the poly bridge node, what it requires us to do is select an edge on this shape. Let's grab the edges selection. And then go ahead and select one of the diagonal edges on this shape. Then we're going to press the poly bridge button up here in the shelf. And then it wants us to select the bridge that is the destination for our polygon. Let's select this edge. And then I'm going to click enter. And this will create a polygon bridge. Now right now it is actually creating a curved bridge. I don't want that. Let's lower the amount of divisions to 1. And let's also set this to straight as well. So this now creates this connection here. Now it has actually dropped this node outside of my netbox. I noticed that's some kind of behavior that tends to happen when you use shelf tools. So let's pull it up here and drop it inside of our invalid icon netbox. Then let's go ahead and offset this icon as well and also use our poly extrude. So I'm going to copy these two, paste them in below. And this will now extrude it, and it will extrude it downward on the grid. Now with that, we now have our basic no icon completed, right? In fact, we could directly plug it in, but we now have 2 icons and we have only 1 copy to points node, at least for the elevators. That's actually not such a big problem as you might think. And that's because the copy to points node has a particular option here called piece attribute. And this allows it to pick one object over another based on an attribute it's actually looking for. And we can do this very easily by adding a unique attribute value to each icon and then adding a unique attribute value to the points that are going to spawn them. So our spawn points over here. Let's go ahead and first create the value on our spawn points, and then we'll assign them to these two after. Let's create a new attribute create node right here on our line. And I'm going to call this one piece attribute for the invalid points, right? So that will be our invalid group, or overlap group rather. So let's make sure that's set up. Over here under our groups, let's select the overlap group, so we assign an attribute to that. And then under the attribute name, let's name this one icon. This is going to be an integer on our points, and its default value is going to be 0. And then if it's an overlapped point, this red point here, we're going to assign a value of 1. So now if I go ahead and visualize that, we should have an icon attribute here. And then under the D menu, let's turn it over into a marker. Okay, so here we have icon value 1, and these ones have 0. Okay, I'm going to color this node dark blue, because it does assign an important attribute. And then let's copy this attribute node here, paste it over here, let's plug it in below. And I'm going to call this one icon 0. And then over here, let's remove the overlap and set it to 0 by default, because our arrows are going to be 4.0. Copy that. Then let's plug it in underneath our invalid icon. Set this to value 1. And then I want to create a merge node for our left channel here that goes to the elevator arrows. Let's grab a merge node. Let's plug these together. So now you can see how we have both icons here, both meshes, overlapping in the same space. Now, if I go to my copy the points node, and let's go ahead and hide these markers, you can see that right now it's simply duplicating both objects, right? Over here under piece attribute, let's change it over to our icon attribute. And there we go. So at this moment, what it's doing is for every point, it's going to check the icon attribute, and then it's going to check if the icon attribute exists either as a point attribute or as a primitive attribute on these pieces of geometry. And then it's going to delete all the ones that don't have the correct value for that particular instance that it's trying to copy. Now, if you're working with primitives, you might have to set these ones over to primitive mode, and this will work too. It might create a better result for you, but either one will work. So with this, now we have our arrows and we have our invalid, no icons. Now I still want to add a different color to these ones as well. And I mentioned, just like before, we could add the color up here, and this will work. But in this case, I'm going to add the color down below here. Let's copy this color node. And let's name this one invalid icon. Let's select the overlap group. And then under here, I'm going to select this red color. Now, if you want, you can also, of course, go ahead and grab a blue color maybe and make this darker. So you have like blue arrows for the elevators and then a blue no icon. But our visualizer is so simple, I don't have to go very elaborate here. In general, all you really have to do is tell the people that use your tools what these icons mean. Maybe even add a bit of text to your tool or a bit of a label to the interface, just to explain what everything means, and people are generally good to go. So with that, if we go to the outside of our tool, then now we should have our icons being displayed. Now in this case, it appears that our no icon is slightly below our actual box. So let's raise this grid up just a bit further to fix that as well. Over here. Let's go ahead and give this a little bit more height. Maybe even more. All right, this appears to be enough. Okay, so now we have a proper indication on where our objects are. And let's go and test it out, right? Let's go to the top of the tool. And then let's grab an elevator curve. Let's try adding some more points here to this particular component. So you can see that it doesn't actually allow points in the same space. The moment we try to overlap them, they will prevent this. And we do seem to have a little issue going on here with some of our extrusion actually. Maybe we should look into this. Now, when you're using your tool, you might notice some things go wrong. And I think I already know where this is coming from. I think it's coming from our bevel node. So let's have a quick look at that before we close up this lecture. And then let's test that in Unreal and we'll call it a day. Okay? So let's recreate our little glitch. So if we put our box here, that's when it happens. Let's go into the tool. And like I said, I think this is coming from one of our bevel nodes. Yes, so here's our floors. Let's hide everything else. And then here we have our bevel node. Okay, so it looks like when our boxes did our cutting, they were basically overlapping each other, right? And like I told you, if you use a Boolean node and you have coincident faces, then it can actually cause some of the cutting to go wrong. At this point, we have some boxes overlapping each other. Let me see, it's up here, yes. And in between them, they do have some faces in between. If I go inside, you can see that we have this overlapping space here. The moment we use our Boolean node and we cut into the floors, something here seems to be going wrong. And well, we should try to fix that. This is something outside of the example files because I only just noticed this now. That's par for the course. If you go ahead and stress your tool and you try different things, sometimes you're going to run into this, right? So we have to deal with that. Let's grab our shaft here, and I know exactly how we're going to fix this. Let's create a clean node right here. And I will have to double check this later with the rest of my code when I finish the lecture, just in case I break something. So we might revise this again, but that's just par for the course. Now the clean node has the option to take any of these coincident faces that we see here, and if they overlap each other, we can remove them. Now under the clean node, let's go ahead and click on Consolidate Points, and this will take the corner points of each of these boxes here and fuse them together, because before they were simply separate elements. This is very similar to a fuse node. In fact, inside the clean node, which is a native digital asset, we will actually find a fuse node right there. Okay? And then below that, we have several other nodes which allow us to clean our geometry, including a polygon doctor node, which is a very interesting diagnosis node for polygonal modeling. I won't go too deep into this right now, but this one basically allows you to detect all kinds of bad geometry, and it can even try to repair it for you. And the clean node has this one integrated into the asset. So we can go ahead and use these under whatever situation we need it for. And next, in order to clean up that primitive inside of this box, we can use the fix overlaps right there. Now there's two options with this one. We can click on it, and that will simply remove whatever overlapping primitives you have. So if you have two coincident primitives here, like we had, it will just remove it. Or we can turn off delete overlapping pairs, and that will only keep one. And this will allow us to merge some of our duplicate geometry. Now, if you keep this one primitive and you feed that to a Boolean node, it's likely it will break In this case it doesn't, but it could break. And that's because the Boolean node does expect clean geometry. Don't underestimate the sensitivity of a Boolean node. If you have a primitive or such like this, where you have a object on the inside, or rather if you have an edge on a primitive that has more than two faces coming out of that edge, so like we have one here, one there, and then one on the inside, then, well, it's likely to break the Boolean node. At the very least, it could break the Boolean node, and that's bad. So let's go ahead and make sure that this doesn't break and turn back on delete overlapping pairs. Now with this, we are now properly Booleaning this part of our building. So that's good. And as long as our mesh is clean, then the bevel node is also returning a clean mesh as well. So yeah, sometimes you have two nodes that in succession can cause an error. The bevel node is pretty sensitive to bad geometry. It doesn't deal very well with zero space geometry. And our Boolean node, if you feed it bad information or coincident faces, can create that type of geometry. So, you know, one thing leads to another, and before you know it, your entire mesh blows up. So that's how we go ahead and fix this. Okay, so at this point, I think we are pretty much done. Let's go and save our tool in its current state. Then let's save our scene. And let's go over to Houdini and test it out on our own asset. So select the tool, re-import. And in this case, I do need to actually import our new delete by distance asset as well into Unreal. So let's grab that one as well. Let's grab the project folder. And then we can drag our delete by distance node into our scene. So it's there. Then I'll go ahead and save everything. And with both these reloaded, re-imported, let's right click, rebuild our tool. And now here we go. We now have our grid on top of our building. If I now go ahead and grab our point, move it around. All right. Now let's try to place it on top of our staircase. See what it does. All right, so now we get a no icon. And we don't have any object being spawned here. If we go inside, yeah, there's nothing inside. So this is working. So with that, we now have proper visualizers for our building. We can use it properly, including see where our sharp corners are. If I go ahead and change some of these settings around, we can go and test that out here. Let's change our corner angle to, say, 80. And that will remove the edge indicators on the corners here. We also have our numbers on the bottom of our tiles. So if I go to my doors and windows, switch this to by pattern. And then let's specify I want a door at points 4, 5, and 8. Okay, and our door here has vanished, so that's good. And then finally, we have our seam as well, which we haven't tested yet. Let's go to the building settings. Let's move our seam over, let's say by 2 units. Okay, so it moves to the right. If I click on reverse, it still moves to the right, but our point order is now reversed. So I think if I wanted to make my seam go in the opposite direction, I probably would have had to go in here and maybe add a separate reverse sort node before this one, before we try to shift it. So we control the shifting direction. Anyway, that's just something that's interesting to note. So with that, our tool is ready. We now have the ability to add our visualizers. We can actually go ahead and use our tool properly now. We have good indication on how it works, and I think our users will be quite happy with that. So in the next video, we are going to start working on the instances for the tops of our building, and we'll also work on the pillars on the inside. Now that we have a properly working delete by distance SOP, we can now go ahead and use it to make sure our objects don't stick inside other objects, and we can set this up real quick. So thanks for watching this video. If you like this video, please go ahead and like, subscribe, or go ahead to my Discord channel. I always like to see what you guys are doing with the project. And for the rest, thanks a lot for watching this video, and have a good one.